Sentry, as we know it, consists of four main pillars. The first being error monitoring. We tell developers that their application is broken, give them all the details, and even show them the commit that caused that error so that we can get to addressing it. The second being release health. This is giving you all the session-specific information, such as crash-free sessions for mobile. And then we have Discover, our query engine, so that you can get any of the data out of our platform that you need and query any of the events and create dashboards. And then we have integrations, right, for issue tracking, alerting, etc. Today we're here because we're introducing a new piece of functionality, or a new pillar as we call it, that being performance monitoring. We'll get to that in just a moment, but for those that are new to Sentry, I just want to do a quick level set of our error monitoring capabilities. So here I have my application and I have Sentry integrated. Here you can see I've imported the package. So if this was Python, this would be pip install, Ruby gem install. Here it's JavaScript, so it's import via CDN, or for Node.js npm install. And then all you have to do is sentry.init. I've done that here with your DSN, which is your unique key associated with your project, and we want errors to be shot up to sentry.io. So I'm going to go ahead and cause an error. When I click checkout, you can see there was an error, and instead of debugging with a log, since I have Sentry implemented, I'm automatically going to be alerted, as you can see here, that a new error happened and that I should go and investigate. So from here, we can then go in, figure out all of the context, the who, what, when, where, why, so error type, error name, how many times it happened. We have similar errors aggregated, and we can even see the user impact. We can see that it flared up, most relevant to the developer, the stack trace. We can see any of the frames that we want and get all of the inline code context, and the breadcrumbs showing what happened in the application prior to hitting the error. So here we can see some items were added to cart, the checkout button was clicked, there was some sort of request, and then an error was thrown. And it looks like this error is happening on all of the various browsers. And it seems like it's only happening in this release, but any tag introduced into our system will produce a heat map to help us understand exactly who's impacted. From here, we understand exactly what went on if we have any knowledge of this code base. If not, we point out the commit that caused the error, so we can directly assign to that individual, and the person best equipped to fight this fire is on the job. Performance monitoring, Sentry's newest and fifth pillar. We don't just want to tell you that your application is broken and has crashes. We want to let you know that your application is slow, and then allow you to drill down on that specific code or service and figure out exactly what's slow and optimize and address. As we push code more frequently and move into a distributed microservices architecture, code ends up breaking for a variety of reasons. We test as best as we can, but it's critical for us to monitor and to be able to address issues effectively as we push into later environments. Sentry addresses this for application errors today and crashes, but a broken app or experience is not always just due to application errors. Slow responses and long loading screens and inconsistent experiences drive users away, right? We've all been there. We use an app and we're calling for a service, we're trying to get food, we're calling for a cab, and it takes too long, the loading screen is up 10 minutes, you don't know if it's working, and immediately we switch apps and use a competitor, and we likely don't switch back ever. With Sentry's new performance monitoring, we're going to be able to trace these issues back to these services, specifically back to the poor performing code. So what's going to happen is we're not only going to ship up errors with our SDK, we're going to enable a new integration to ship up transactions, and now we're going to be able to see how long things are taking in the front end, in the back end, in microservice 1, in microservice 2. So we're going to be able to answer questions such as, did my last release introduce slowness? Are things out of the ordinary baseline? What's slow? Is it my back end? Is it my front end? Am I issuing too many API requests? Are they synchronous, or should I parallelize them or lazy load, etc.? Alrighty, so let's get right into it. I'm going to be demoing today in JavaScript and Python, my front end being in React and my back end being in Flask. Today we have this integration and performance available for JavaScript and Python, and we're rolling out this feature set and capabilities for the other SDKs in the near future as well. So more to come on that soon. Stay tuned for your tech stack. But with that being said, what I'm going to do first is showcase exactly how this is integrated within the front end in React. So we'll go over what we need to do in the SDK there, as well as in the backend in Flask, and then go ahead and talk about the information that we're shipping up, the transactions, and then view this within Sentry to figure out exactly what the slowdown is. I'll also explain each screen and interface step by step so we understand what we're seeing and what the data is here. All right, so let's head over to Sentry. Let's go over to the documentation, and on the left-hand side, we're now going to see performance monitoring. Let's head on to getting started, and then install and configure an SDK. And from here, we're going to start off with JavaScript, and then we're going to do Python. But first step is installing the SDK, so yarn add, npm install, or cdn include, and then sentry.init, the DSN. And the only thing new here will be integrations, new npm integrations.tracing, as well as traces sample rate to specify what percentage of traces that we want sent up to Sentry. You can see right here, this is where it's imported. So let's go on into the code and showcase this. So here we have sentry.init within my React app, my DSN, and then the integration, new APM integrations.tracing, and then tracing origins just to specify which requests I want instrumented for tracing. And then in this case, for this demo, I want all transactions being sent up to Sentry. And then on the Python side, back to here, Python, pip install, import it, Sentry SDK.init, the DSN, and all you have to do on the Python side is traces sample rate. So here is my Flask backend, import Sentry SDK, DSN, and then traces sample rate right here. Now that we have the SDK wired up to send up transactions to Sentry, let's talk about what's going on under the hood. So here we have the distributed tracing documentation, which talks in depth about what tracing is, what it's supposed to do, what it's not supposed to do, as well as maps out traces, transactions, and spans. So what's now happening is the SDK, as I mentioned, is shipping up transactions into Sentry. So let's go ahead and quickly define each of these. A trace represents the record of the entire operation that you want to measure or track. For example, a page load or an action within your application. So in our case, it's going to be a checkout. When a trace is going through multiple services, each one of these is called a transaction. So a transaction represents a call into each one of your services or microservices. Inside your microservices, you have a bunch of function calls and code executions. Each one of those is a span. So in our case, we're going to start off with the page load, which looks something like this. So it starts off in the browser, requests out to the backend, and then it'll connect out to the database server. And you can see how the spans are linked to various transactions. And all of this constitutes one trace, that being a page load. And the second example we'll get into is checkout. So now that we have the SDK configured and know what's going on under the hood, let's go ahead and establish a use case. So here you can see I'm loading my application. It took quite a bit of time for the tools and the inventory to load here. That's going to be the first thing that we're going to debug. And second, we're going to go ahead and trigger a checkout. And here we have a request that went out to a backend and there was some error. We'll investigate that later as well. So here, I'm just going to reload this one more time to show you all what's going on. There's a request out to the backend. It took some time to load it. Here you can see a transaction got shipped up as well to Sentry. And then when we hit a checkout, here another transaction got shipped up, in addition to also an error, which we'll link up and talk about and discuss as well. Now that we have transaction data shot up to Sentry and know what's going on under the hood, let's go to sentry.io to view this data and debug this use case. So by default, you're going to be taken to the issues list, but what we're doing here is interacting with transaction data, so let's go and head over to the performance homepage. Here is the main view where we can search and browse for transaction data, We can filter by any search conditions or choose from a list of sortable transactions in the table. We can also drill down on this data to narrow in on the time frame as well. So here, just for example, let's go ahead and just view this subset of events here. And what we see here are all the transactions, the projects that they're associated with, the transactions per minute, P50, P95, as well as failure rate, app dex, user impact, and user misery score, which is defined here as well. On the top here, we're going to have two tables that we can see side by side. AppDex is generally a good place to start out with. So in case you forgot what that means or don't know what that means, here we have a tool to help you. So here in this case, AppDex is the ratio of both satisfactory and tolerable response times to all response times. And we may want to view that to all the transaction load that we're seeing. So here we have TPM, transactions per minute, or we might want to see the P95 duration, which is the duration that 95% of transactions are faster than. In this case, we want to debug the page load transaction and figure out exactly what the slowdown was from there. And then, as mentioned, we'll move on to the checkout flow and debug there as well. So just to start off with, I know that this was in my front-end project, so I'm going to add that to filter. I can see all the various transactions here. And this was the page load request for this URL. So search and drill down. And then clicking into this will take me to the summary view here. On the transaction summary page, we're going to be presented with various types of information relevant to this transaction, where we can understand its overall health. We'll find graphs, we'll find facet maps, as well as related errors, and the table of the specific transactions, which we'll drill down in a moment. So first, the graph. By default, it shows a breakdown of the duration, but we can also view a duration percentiles, as well as get a histogram of the latency as well. On the right-hand side, we're going to have the performance-related metrics that we were referencing earlier. So AppDex, user misery, transactions per minute, and highlighting this will showcase that in this specific point of time as well. Let's take a deeper look at the graph and switch back to duration breakdown. So now what we can see are all the different P100s all the way down to the 50. We can see that a release was introduced at this point in time. And, we've spiked up to 11-second load times that are affecting pretty much everyone here. So let's go ahead and debug further here. So in this case, I've already filtered by the slowest transactions. So I'm going to go ahead and click in. And now I am on the transaction event details page, where I can see the entire transactions and all the spans associated with it and other information. So now we've drilled down on the transaction and are on the transaction event details page. And here we can see the entire transaction and the associated span tree. We also have an associated minimap, which allows us to drill into any time frame if necessary. Here in this case, we already have a glaring culprit, which is this pink box, this get tools request, which we're going to debug in one moment. Underneath the span tree, we have breadcrumbs, and this is exactly what you're used to with error monitoring. So what happened in the application prior to the transaction. And underneath that is all the additional information picked up by the SDK that's relevant to understanding what's going on with this transaction and who it's coming from. On the right-hand side, we'll have some aggregate information. So we already saw that the glaring pink box is the culprit here. It happens to be an HTTP request, which took 99% of the time here in regards to the whole transaction. Underneath that, we'll also have the event tag details if you need to understand who exactly the event is coming from as well. So now let's go ahead and drill down into the glaring pink box here. So the tools request, and then go ahead and click View Span. And now what I'm looking at is the transaction event details for the Get Tools backend request here. So you can see it hit the server, and here it went to fetch all the tools, initiated the connection to the DB, and then running the query took a whopping 10 seconds. So this is what we should drill down on. We can also see this right here, that 50% of the time was taken by running that query, and that this is probably the optimization that needs to be made, or the investigation that needs to be kicked off in regards to improving the performance here. So what we've done, just in summary, is we started from the front end, right? Got to this transaction, figured out that this was taking 10.9 seconds, clicked in, and then traced this to the back end here, where we saw what was going on with that layer, and here the query from that 10.9 seconds consumed 10.8 seconds. So now from here, the backend developer would presumably fix this, and what we would see essentially is in this, let me just kind of refresh out here to the last 24 hours, is a new release that would have been created somewhere around here, and all of these times drop. So to tie this all together, I'm going to start from the beginning real quick and go from there. So we started at the front end page load transaction. We figured out what some of our slowest transactions were. We're able to understand the state of things here, look at all of the performance related metrics on the right hand rail, and then drilling down into the front end side of things, figuring out that this is where the most time is being consumed, and this is why the user was not able to see the inventory and was presented with a loading screen. Drilling down into the associated backend request through our Flask backend and figuring out what exactly was slow and any other information that would allow us to investigate that piece of code to potentially optimize and fix, thus seeing the performance and the times going back down. So let's move on to our second use case, which was the checkout flow, where we added a bunch of things to cart and click checkout, and we had an error as a result of a backend request. So here, what we've done is we've instrumented our checkout to create a transaction, and we could create any of the spans accordingly as well. So here is some sample code very resemblant of that. Here we've started up the transaction. Then you would have any of your business logic in between that, and additionally spin up any spans as necessary. And when you're done, go ahead and conclude all of that, and that will ship up the transaction. If this is not done, then once things become idle, the transaction will then be flushed out with all of the appropriate information contained in it. So let's go back to the performance homepage and figure out exactly what's going on with our checkout transactions. So here I've initiated a search over the last 30 days on all of the checkout transactions. What we are going to do is start at the front end and drill down into a specific transaction. And as expected, here we can see it's issuing a request out to our checkout endpoint on our Flask backend. Let's go ahead and view that span and go into Python Flask territory. Right off the bat, we can see this red font, and it says that there's an error associated with this transaction event. So clicking into here, we can see that an error occurred in the span. I pulled it up here up in a new tab, and now I'm looking at the error event also associated with the transaction event. And as you would expect from Sentry, all the details, the who, what, when, where, why, this error likely caused that slow transaction or had something to do with it, and this commit caused it all. So what we've done is shown that this transaction was possibly slow or likely unsuccessful because of this error, and you probably want to investigate this as well. So all your errors, all your transactions in one place, so you can understand not just application health in regards to, is it working? Am I having errors or crashes? But is it slow? Are all of these things related? So here in this case, we started triaging the issue from the performance homepage. But in our day-to-day developer workflow, we likely don't want to just be triaging issues and starting from scratch and going from there. We likely want to be alerted and then react accordingly. So let's go ahead and set up an alert for when our page load goes beyond a certain threshold, and we want to be alerted on Slack. And let's actually do it only for our most important logged in customers. So to start off with, let's once again go back to the performance homepage. I want to start off with all my projects here, and let's do transaction.op page load. And this is my web page right here. And directly from within here, you'll see create alert. Go ahead and click on that, which takes us over here where we can create a metric alert to alert us when things are outside of our defined norm. So first things is we're going to define a rule condition, and we want to narrow down on the specific types of transactions that we want to be alerted on. So already we have this pre-populated here, the page load transaction and the specific page loads, but this happens to be the web page that we were looking at. And to establish context, I'm going to make this a little bit more difficult for myself by only having this applied to logged in users. And you can see I queried that and the graph refresh right here. And I also want this to only apply to my enterprise customers. So basically, when my enterprise customers that are logged in have a page load that's beyond acceptable, I then want to be notified. So here in this case, I'm looking at the count. So this just shows me the number of matching transactions here. But what we're actually interested in is a time-based metric. So let's say P95. So 95% of my requests should be below 4 seconds. And if they're not, we then want to know about it and do something about it. So here I've selected P95. Our alert will be evaluated every minute, applied to all the different environments. And you can see here, it has spiked to almost 6 seconds. And down here is where we will be able to define those thresholds. So 4,000 seconds, or 4,000 milliseconds is what we talked about there. And then 1.2 seconds is when we'll say this will resolve. And you can see that this graph here was reflected accordingly to show the resolution and the trigger threshold. Lastly, we need to define where we want to be alerted. So in this case, it's going to be Slack. And I want to be alerted in this Slack channel, as well as give this a name. So here we have page load for enterprise, for logged in enterprise customers, more than 4 seconds. So that's saved. You can see metric alert right here and the corresponding alert and a summary of it right here. Here is our rule that we just configured. So we can see it's a metric alert right here in the name. And here is what it looks like once it has fired. So as we did specified in the action, we wanted to be alerted on Slack. Clicking into this will take us into this alert view where we can see exactly what went on, why it was triggered, and kick off the remediation process here. We can even go to get more details directly from here to assist. So here I'm letting everyone know. You can then go to view the transaction summary, and this is a familiar screen. Now that we've covered alerts, the last subject is querying the data that you're sending in to Sentry in regards to transactions. So let's go ahead and pivot over to Discover. You may have been familiar with this in regards to error monitoring. So Discover is our query engine tool that allows you to slice and dice the data, as well as create your own dashboards and really analyze any of the data that you're sending in into Sentry. The same is going to be true for transactions as well. So everything for the most part is indexed. You can go ahead and create any of your queries as such. And you'll also be able to do some basic arithmetic such as more than and less than, so that you can find the relevant transactions and really drill down as you need. Let's go ahead and create a dashboard or query for our slow transactions. And we'll define this as a P95 more than a certain time amount. In addition to that, we're going to want to know the total number of transactions, as well as how many unique users are responsible for those transactions as well. So let's go ahead and get started here. So first things, let's define the data that we care about. I'm going to start simple here. So let's just start with transactions, and we want to know the total number of transactions, as well as how many unique users are associated to those transactions. So here we can see the data set has been queried. We have the results. Here's checkout and our page load transaction that we've been toying around with. I'm going to go ahead and narrow down the data set here as well. Here now, what we see is the transactions, the total number of them, how many unique users have been impacted, and we also want to list out the P95 and the AppDex here. You can go ahead, drag and drop to just restructure however you like here. And here we go. So now what we have here are some metrics, P95, AppDex, as well as the total count and unique users. I'm going to go ahead and filter accordingly. Let's say my definition of a slow request here is P95 more than 3 seconds. There we go. Now that we've honed in on this data, let's go ahead and analyze this further. So what we're seeing here is the total period and the count. So we're seeing the total number of transactions of this query here. What we're actually interested in is dividing this out. So let's go ahead and select top 5 areas. So this will color code this, and we're still looking at the count so we can get the entire breakdown here. And this makes sense as they're the same as the front end requesting out to the back end in all of these cases. And as we were discussing earlier, we're not interested in the count, but rather the P95. And now we can get a breakdown of the P95 times on this data set that we've honed in on. If we want to pivot on this data further, we can go ahead and add anything to filter from within the table, as you might have seen me do earlier, or select any of these tags, which will then refresh the data set accordingly. So for example, to stick to my earlier example, if I wanted to see the enterprise specific stuff, I can go ahead and click that as well. Let's go ahead and now save this data set or dashboard so we can access it next time we want to know P95s that are more than 3 seconds that are important to us. So here, go ahead, click Save As. I'm going to say transactions with P95 more than 3 seconds. And we can go ahead and save that as well for easy access. So that covers our introduction into performance monitoring. We started off with showing how this integrates within the SDK, and then showcasing how the data makes it up to Sentry, looking at these transactions from the performance homepage, the summary details page, all the way into the transaction details page, finding the slowdowns, drilling down into the appropriate spans. Then we covered alerts and how we're able to set those so that we're programmatically notified when things are outside of the normal baseline. And lastly, we just covered Discover, where we can query any of the data that we're sending into Sentry, so we can drill down on any of the transactions that we want, figure out what's out of line, and find correlations, as well as pin these queries for easy access and sharing with the rest of the team. I want to end off with a few different use cases of where we've used this on ourselves, or the popular term dog fooding. So we're going to go through 4 of these. The first one happens to be one of our most popular endpoints, and we had gotten some complaints or heard back from customers that things were slow on one of our most popular web pages, and we didn't quite know what was happening right up front. But after tracing it, we then found out it was due to having a large amount of projects, and the way that we had implemented our endpoint was not efficient for those when retrieving a large amount of projects. So long story short, we made the improvements over a 2-week sprint here. You can see that we got the time, the P95 time down from 1.2 seconds, initially down to about 900 milliseconds in the first release, and then through some iterative releases got it all the way down to 300 milliseconds. So quite a bit of improvement here from 1.2 seconds to 300 milliseconds within a couple weeks. So initially we were able to trace this down, optimize the endpoint accordingly. So what we ended up doing is batching it as necessary, and we were able to verify the performance improvement here. This next dog food example I want to go over is very interesting. So on our issues page, releases pops up in a variety of places, and it looks like the way we have this implemented, or had this implemented, we were hitting the same API multiple times and not caching it or not reusing the result when necessary. So on the front end side, this was providing a poor user experience as things were loading at various times inconsistently, as well as there was more heavy lifting happening in the browser that did not need to happen. But more importantly, we were issuing more requests than necessary on our backend. And this is something we had realized but didn't quite know. The more we investigated this is what we figured out, that we're hitting this too often, that this can be improved on and optimized. And that's exactly what we did. So the end result was this no longer looked like what we see here. We were only hitting the API absolutely when necessary. Otherwise, the result was cached, and we were pulling from that. The next two dogfooding examples I'm going to go over via blog post. This next one is pretty personal to me because it was actually when I was demoing a new feature of ours and it took too long to load, and our head of product took it upon himself to figure out the answer. And dog food example number 4 is one of our engineering managers debugging his way through why our new alerts view was taking too long to load and was slow. So let's head over to the blog and load up both of those blogs. So the first one, as I mentioned, it involves myself. At first, everyone was blaming my internet connection as I was demoing our new release health feature. And then Dave went through figuring out what exactly was going on here and figured out in the end that it was this Teams endpoint and routed it to the right team, thus avoiding a big escalation crisis and having a raging Neil going around the office flipping tables. The final dog food example was our engineering manager who wanted to figure out why the specific alerts view was really slow. So here you can see he himself used Discover to figure out and develop the query to figure out the P99 is 12 seconds and 9 seconds for some of the folks that work at Sentry. And this is unacceptable. Obviously, we can't push this to production like this. This would not be well received, and we would hear about it pretty soon. So from there, we got it in the hands of our experts. So this is what it looked like before. And a big problem was that we were loading all of these stats that we didn't need to at our initial page load, which made the whole page load seem slow and absolutely wasn't necessary in terms of the whole experience to know about up front. So we got our experts on it. You can see loading is very little, as well as we're loading the critical API request first, rendering that data, and all the stat stuff and the graph stuff that isn't critical up front is then being put out for later. So what we've shown in these examples is that we were able to find the slowdown, whether it was on the front end or the back end, address it, and verify that we were fixing the right thing and the user experience was improving, seeing the P95s or whatever relevant metrics go down or up depending on what they are, and thus iterating accordingly, and then proactively setting alerts as we need to make sure things aren't out of the ordinary. The point being is that we want to let developers know the quality of their code, not just regarding errors, but regarding the performance, how the code is behaving, how long things are taking, should they be concerned, or go back to developing new features, bug fixes, and improving the product that they're working on.
All right, awesome. That's good stuff, Neil. Thanks so much. We're going to open it up to Q&A. We have been joined by, in addition to Neil, our VP of Engineering, Ben Vinegar, is here to answer questions as well. So I'll go ahead and start teeing those up for you guys. The first one and most widely asked question is around availability by plan type or availability by language. Can you all speak to what we're starting off with and what's going to be rolling out in the near future?
Yeah, no problem here. There's more information to come on this soon. Today, as we mentioned, we're soft launching this and showcasing this. I believe this will be available to all plans here as we want you all to experiment with these transactions and see what value you get out of it. And there will be a free trial, which Schaefer will cover as well, so which you can launch going into our product and get started from there.
Cool. Yeah, and just to answer that question as well, how do you get started using this today? If you can see my screen, if you just go to your settings in Sentry, click on subscription, there's a little button there in the middle that says activate your trial, and that'll get you started on a 14-day trial of our new performance plans. Cool. Next question. How does Sentry is, sorry, one second. Can this be configured for Apache Airflow?
Yeah, so this isn't something we have official support here just yet, but we've actually been doing quite a bit of investigation into this type of data flow and ETL space and what we can surface there for those developers and folks that work on those stacks.
Cool.
I think in the comments, hey everybody, it's Ben here. I think in the comments for the Q&A, actually one of our engineers responded with a link to the Airflow repository with the relevant code. So I would take a look, but it is probably unofficial right now.
Cool. Does the front-end SDK differ from the back-end SDK?
Yeah, I'll take this one on. So since it's two different services, there will be two different SDKs in there. So in my example here, we had a React front end. So I integrated the JavaScript SDK into that. And we had a Python Flask backend, and I integrated the Python SDK into that service.
Cool. Next question. How does this compare to AWS X-Ray?
Yeah. So here you can see that one, we're shipping up errors and transactions, and we're all doing this at a developer level. So at the application code level, here we also started with the front end and the user experience and debugged its way into any downstream systems. Tracing is necessary, and you can see some of the integrations and workflow stuff that we have built into Sentry isn't typically there in some of these other solutions as well. So a solution for developers so that they know, the errors and performance of their code and have a proper workflow around alerting, issue tracking, and actually solving these and acting on them and going from there.
Great. Is it open telemetry compatible?
So here what we're doing is we're using the same spec, but our concept of transaction is actually something Sentry specific. Right now, it doesn't work with a native open telemetry collector, but we're in the process of exploring how we can better leverage some of this in the future.
Great. Any information you could share on the pricing model?
As we mentioned, we'll be soft launching real soon, so you'll see it right there, but it's going to be very similar to what we have existing. You pay for what you use, a bucket, but once again, we'll refer you right to the docs, and we'll be soft launching this really soon, so don't want to take away that thunder.
Will Sentry Performance Monitoring increase build size for React.js?
Yes, slightly. So as we saw earlier, we're bringing in another integration, which is a different bundle, but it shouldn't be noticeable here or anything.
Cool. How is the trace ID passed between spans on different systems?
Yeah, I think this was asked in a couple instances, and someone guessed it right. It's custom headers being passed. So you'll see a trace ID and a span ID as a custom header that's being basically automatically generated and attached on as a header, and also received and acknowledged.
Cool. Next, what is the performance cost of tracing? My main interest would be for JS front end and Node.js backend.
Yeah, so here, just like we've done in the past, with our SDKs, we've taken on the approach and philosophy that we want to be minimally invasive and that we don't want to impact the application or instrument anything that we don't need to affect the application. So it should be very, very minimal. There shouldn't be anything where it should be too noticeable here, but more to come on this as well. So go ahead, integrate it in, check it out. It shouldn't really be much there. We've been using this quite some time and, have some other folks on it. And this has been good there.
If I could add, I would say, a key thing is that it's agentless. So it's about library instrumentation rather than, something that's running alongside your code. So you can imagine the overhead as being very similar to, I call a function, I start a timer, I close that function, I end a timer. Like the overhead is very light.
Cool. Next question. How does Sentry protect against user-facing slowdowns directly related to calling into its API? either due to connectivity issues or Sentry server response times? Is there an analytics overhead performance report?
Yep. So the question was, how does Sentry protect against user-facing slowdowns related against calling to its API? This is exactly what we have basically debugged here, right? The get tools request was really slow, and then we trace that into the backend and figure out exactly the slow issue. And if it was a connectivity issue or a server issue, it would have shown up accordingly. And if the information that you don't expect is there, then you would instrument additionally as needed. In regards to an analytics overhead performance report, there is some reports that are already pre-built within our platform, but we've created Discover for this very reason, that you can create any dashboards within a couple clicks and share these and leverage these however you want, whenever you want, and going from there. So we wanted you to interact with our open query engine to define what you want and then go at it from there.
Great. As you're monitoring everything on the client side, is this going to affect client side rendering browser memory?
As we talked about earlier, we are bringing a different bundle, but the instrumentation is quite light. As Ben alluded to earlier, it should just be a matter of, simple function calls and starting timers. So not really.
Yeah, I mean, so we've been betaing this for maybe 2 months with customers, and we haven't gotten any feedback of the sort that says, the overhead is too high. People have been pretty happy with how this has gone down. I know it sounds very anecdotal, but ultimately we do not instrument every function call, right? So it's more about instrumenting kind of like higher order calls that are more meaningful for you. So imagine, outgoing HTTP requests, for example, right? That's way more manageable than trying to instrument every single function call that your code might be making, especially if you think about like a React DOM reconciliation, which could be incredibly expensive. So because of the approach that we've taken, it's intentionally designed to be lightweight.
Cool. Next question. You mentioned an option to create a dashboard from discovery. Can you elaborate more about this?
Yeah, I mean, I think that this was covered sort of in Neil's video. Again, we're going to send this out, the recording, but effectively you can change the graph. You can change what columns you're interested in. We provide a lot of functions on our data, right? So you can run a percentile on transaction, right? So if you want to graph P80 times, you can do that. If you want to graph unique users over time, there's a lot of flexibility in what Discover provides. You can save that query and then it sort of like lands on the Discover dashboard, so you can come back to it at any time. Hopefully that answers the question. Neil, I don't know if you have anything to add.
No, I was going to say that, except I said it on mute.
Cool. There will be a lot of data transferred. Where do you host the data? Do you have instances that work for sensitive customers, say in the EU or Switzerland?
Mm-hmm. Yeah, I'll take this one. So what I was showing today is Sentry.io, which is our multi-tenant SaaS solution. And we have the ability to spin up any single tenant solutions as well. So we could have a deployment out in the EU or any region of your choice for you and your company where the data and infrastructure is isolated just to y'all. And then, as I mentioned, we have multi-tenant and we are an open source company. So you can spin this up for yourself on your own machines as well.
Cool. What happens when you don't instrument a transaction? Do you only get page loads by default?
Yeah, so on the front end side, it will be page load, I believe, and then it would be up to y'all to do anything post page load in that session. And then on the back end, you'll have the API level instrumentation. And as we've been talking about earlier, that kind of goes down as deep as Ben said.
Cool. Let's see. Looks like we've answered all the questions in the chat. If we didn't get, actually looks like one other one just came in. I'm going to ask this one in real time. No pressure, guys.
Mm-hmm.
How does the front-end client decide which interactions constitute transactions? In their example, they say in an SPA and navigating between dashboards, the meaningful transactions may be the dashboards populating. Is there manual control over that, or over which functions get measured as child spans within that transaction?
Yeah.
Happy to answer this,
Go
Neil.
for it.
So what we're trying to do here is that when you install the library, we try to instrument common sense, meaningful transactions. So that's page load, for example, for a really basic web app. We're working, for example, on a React router integration that will also capture navigation changes and reflect those as transactions. And similarly, we do sort of like framework level instrumentation to work with your framework to, come up with meaningful transactions. Django is another example, right? We know when a request comes in, request goes out. On top of that, we provide a lot of documentation to help, you can define what a transaction is ultimately, and we are playing to that use case. So if it is meaningful for you that you capture a, some sort of widget within a larger page as its own transaction, you have the power to do that. I know there's been a lot of React questions. So as an example, we provide a higher order component for React that you can just sort of wrap a component that will just sort of like, instrument that. You can introduce something to instrument things as a transaction as well. Does that seem appropriate, Neil? Anything to add?
Nope.
Yeah, I would say that, even in our case in Sentry, we do have the automatic instrumentation, but we've also sort of made those decisions for ourselves and done manual instrumentation where it makes sense in the way that the question asker has asked.
Cool. Awesome. We had over 80 questions. I think we answered a majority of them. If there's any that were left unanswered, we'll be sure to follow up with you via email. I did want to reiterate a couple things as we wrap up here. First, again, if you want to activate your performance trial, you can just go to settings, click on subscription, and there should be an activate your trial, big purple button right there in the middle of the page for a 14-day trial. And yes, this webinar will be recorded. It will be made available to you early next week. We're going to timestamp it so that you can hop to any section that you want really quickly without having to kind of search through. So be on the lookout for that email early next week. I want to thank Neil again for and Ben for being here, and Neil for producing all this content, and all of you for joining us. We're really excited about this new product. We hope you'll try it out. And if you have any questions, you can reach out to us, performance-feedback@sentry.io. I will include that email in the email that I send you. But if you have any questions between now and next Monday or Tuesday, it's performance-feedback@sentry.io.
And Schaefer, just to clarify here, you can activate the trial in the next couple of hours as we're rolling it out right now.
Oh, that's a good clarification. So if you don't see this now, try it again in a couple hours, or just wait till tomorrow. Awesome. Thank you, everyone. Be on the lookout for the email next week. Have a good rest of your week and weekend. Thanks for joining us.